Welcome back, everyone, to the deep dive. Today, we are going to take a deep dive into a pretty interesting antifungal drug. It's called Nystatin. We've got some material from pharmaceutical biotechnology, and we're going to figure out how this drug actually works, why it's important, all that good stuff.
Sounds good to me.
So let's just jump right into it. What exactly is Nystatin?
Well, nystatin it's an antifungal antibiotic, and it belongs to a class called polyene macrolides. Basically, it is produced by a bacterium, and you might know it by its brand names like mycostatin, for example. And the key is its structure, actually, its molecular structure, which is really unique and allows it to target fungi.
Okay, so you said polyene macrolide. I was looking at the source material here, and it mentions a large ring structure, something about double bonds, there's a mycosamine sugar attached. How does all of that actually help fight a fungal infection?
Yeah, so this is where it gets really cool, actually. This specific structure, the way that it's set up, allows it to interact with the fungal cell membrane in a very specific way.
Okay.
That large ring, for example, with its double bonds, it has like a really strong attraction to a specific type of fat that's found in fungi. It's called ergosterol. You could almost think of it as like a very specific magnet being drawn to a piece of metal.
Ergosterol. Okay, so that's the key structural component that's pretty much unique to fungi. So what happens when the nystatin actually latches onto it?
Well, once it binds to the ergosterol, multiple nystatin molecules they cluster together, and they begin to form these tiny channels or pores
Uh-huh.
that go right through the fungal membrane.
Oh, wow.
And this is called a barrel stave mechanism. It's pretty interesting. Yeah. Basically, the molecules, they arrange themselves like staves in a barrel to create these openings.
I see. So almost like they're punching holes in the cell.
That's a great way to think about it.
Mhm.
And these leaks, as you can imagine, really disrupt the balance within the fungal cell. So essential things start leaking out. It can either cause the cell to die directly, or it can stop it from growing further. Yeah, and the effect really depends on the concentration of nystatin. At higher concentrations, it's lethal to the fungus. It just kills it. But at lower concentrations, it's more like it just stops it from multiplying. It's more of a fungistatic effect.
Okay, and so this whole ergosterol thing, that's why it's generally safe for us, right? Because
Yeah.
it's not going after the stuff in our cells.
Exactly. It's all about that selectivity. You see, nystatin has a much higher affinity for ergosterol and fungi compared to cholesterol, which is the main component of our own cell membranes.
Right.
So by targeting ergosterol specifically, it minimizes harm to human cells.
It's like a silver bullet, right to the problem. So with this targeted action, what sort of infections would you actually use nystatin to treat?
Well, it's mainly used for what we call localized candida infections.
Mm.
These are infections that are, kind of on the surface because nystatin isn't absorbed very well into the bloodstream.
Oh.
So think of things like diaper rash, right? That's a common one. Or thrush, that's oral candidiasis, in the mouth. Even like mild esophageal infections, vaginal yeast infections, infections around the anus.
Okay, so really focused on kind of like surface level infections then.
Mm-hmm.
What about preventing infections? Like if someone's at higher risk of getting a fungal infection, can nystatin help with that?
It does have a bit of a role in prevention, particularly for people with weakened immune systems. So think AIDS patients, transplant recipients, people undergoing chemotherapy.
Uh-huh.
It can really help them because during strong antibiotic treatments, there's a risk of candida overgrowth, you see.
Mm.
So nystatin can help keep that in check.
Oh, okay.
Yeah. And sometimes it's even used in newborns to prevent thrush.
That makes sense. So it really comes down to the fact that it's not readily absorbed into the bloodstream. That's why it's mostly used topically, right?
You got it. It's all about delivering the medication right where it's needed, whether that's a cream on the skin, liquid swished in the mouth, or even like a vaginal suppository. And because it's not absorbed well, it stays put and does its job locally.
Okay, and you mentioned that it's not broken down by the body in the same way as some other medications. What happens to it then?
Well, if it's taken orally, most of it is just excreted unchained in the stool. It's not really metabolized.
Okay. So given that minimal absorption, it sounds like the safety profile is pretty good. What about side effects, though? What kind of things might people experience?
Well, the good news is that because it's poorly absorbed, serious side effects are pretty rare.
Okay.
Sometimes you might get some mild local irritation with the creams, or if it's taken orally, maybe some mild stomach upset or a bad taste in the mouth.
Right.
But overall, nystatin's generally very well tolerated.
Okay, so just to kind of wrap things up here, nystatin, it's a really targeted antifungal. It goes after the ergosterol in fungal cell membranes, punches holes in them, essentially. And it's primarily used for localized infections with minimal side effects, all because it's not absorbed very well into the bloodstream.
That's a perfect summary. You've hit all the key points there.
Wonderful. And to all our listeners out there, we hope this deep dive has given you a really clear picture of what nystatin is all about and why it's such a valuable tool in treating those pesky fungal infections. But here's a little something to think about.
Okay.
We talked about how nystatin exploits this unique feature of fungi, this ergosterol, right?
Oh,
What other unique, very specific molecular differences might exist in other types of harmful microbes?
that's a good question.
And how could we potentially target those differences for even safer and more effective treatments in the future?
Lots to ponder there.
It's definitely something to think about. Until next time.
Yeah.